My name is Marek Potočar and I'm a software engineer at Oracle. Let me also introduce my colleague Jakub Podlešák, who is also a software engineer at Oracle, and we together work on Project Jersey, which is an open source project for providing the implementation of RESTful API for developing RESTful Web Services API in Java. It's an Oracle-sponsored open source project, and it's part of the larger project Glassfish. So Jersey is the implementation that's being included as part of the Glassfish application server by default for providing JAX-RS API implementation. Jersey also provides a RESTful implementation for JAX-RS API, and by the way, I'm the JAX-RS API specification lead also. So on top of working on the implementation, we are also coming up with the API. And today we are here to talk to you about what's new and coming in the next major release of Jersey 2.0, which will be focused on providing the reference implementation of JAX-RS 2.0 API that will be released sometime very early next year. Currently, on last Friday with JAX-RS API, we published the public review of the specification, public review draft of the specification, which means that currently there is some period where you can all look at the API. The API should be already stable, and you can provide us the feedback. Anyway, in this session, we are really not going to talk about the standard stuff. We are trying to reach beyond what's in the standard and what you can just do with JAX-RS, and we are going to look at how you can use some of the Jersey specific features so that you can develop your web services maybe more conveniently, add more conveniently additional features that Jersey provides on top of the JAX-RS API. So why we are coming with the why did we decide to come with the major release of Jersey with Jersey 2.0? If you look at the diagram, you can see that in 1.x version there was a JAX-RS API, and then Jersey provided the implementation for the API and also added some additional features such as filters, client API. It also had some internal injection manager. I will talk about it a little bit later. And all those features were missing in the JAX-RS 1.x API. So that's why Jersey was providing these features as a proprietary extension to the JAX-RS API. And since this is changing in JAX-RS 2.0, so in JAX-RS 2.0, basically the client API, filters and interceptors, and a bunch of other stuff is becoming part of the API. It means that the API becomes standard. At the same time, it's a little bit different API. So if you ever used JAX-RS, if you ever used Jersey API before the client API, all the filters, this API is similar, but it's at the same time not backward compatible. It's different. It sits in a different package, obviously. It has a little bit different signatures on methods, and it's more mature, I guess, and even more advanced than the original API provided in Jersey. So with that, we said, okay, so in Jersey 2, we are going to focus on adding some additional cool features in the API, such as programmatic resource builders, chunked I/O support for JSON, SSC, and such. As well as we decided, hey, it's probably a good time to rethink our philosophy, how we are internally designing Jersey code base, and we decided to take the proprietary Jersey injection manager that we spent quite a lot of time on updating, keeping up to date, and providing support for, and we decided to ditch it and replace it completely with the off-the-shelf solution, basically provided by HK2. So it's the same injection manager that Glassfish is using, and we are basically now deferring to that injection manager instead of having our own proprietary Jersey injection manager. So also the layering changed. Why I'm mentioning this? So
I have a question. If you have application in JAX-RS 1.0 and if you're migrating to 2.0, is there an easy migration path?
So the question was if you have the JAX-RS application 1.0 and you are migrating to 2.0, if there's an easy migration path. Yeah. Okay, so just to answer this question, the backward compatibility is in the Jersey proprietary APIs. Backward incompatibility is in the Jersey proprietary APIs. Obviously, JAX-RS as a standard Java EE API must be backward compatible. So if you have only JAX-RS applications, there is no problem with migrating your applications. You can just in the 2.0 API, we are adding new features. We are not changing any signatures. As a matter of fact, we are not allowed to do that. We just very briefly changed some signatures, and suddenly all the tests started to fail. So we obviously had to immediately revert all those, even those very minor changes that we even thought would not impact the API. So in the JAX-RS API, we really make sure to retain the backward compatibility, and there is no problem with migrating applications. Anyway, you reminded me of something. What I wanted to ask you, we are going to show some code, and I'm not sure. Do you want to take the questions as we are showing the code, and the risk that we are not going to show you everything we want to show you today, or do you want to keep the questions for the end? With a little bit of risk that we are not going to be able to show you everything we want to show you today. So who wants to take the questions as we are showing the code? Please raise your hands. Okay, only a couple of you. So who wants to really defer to the end? Oh, okay. Okay. Who doesn't mind? Who doesn't care? Okay. So I think we are going to take the rest of the questions hopefully in the end of the sessions, and if we don't make it and they will kick us out, we'll be kicked outside, and you can approach us and we'll talk about that. Anyway, so let's move quickly a little bit more about the Jersey 2.0 project. So what we are doing, as I said, Jersey 2.0 aims to provide the reference implementation for JAX-RS 2.0. Since Oracle is leading the spec and Jersey is Oracle-sponsored project, it's typical that the reference implementation is coming from the spec lead company. The prototyping of the project, the early work started in 2011, and in that phase we basically decided to really, as I showed you those diagrams, not only the diagrams are different, we are really talking about completely different code bases here. So Jersey 2.0 has nothing to do with Jersey 1.0 code base. We just made sure that we migrated all the Jersey 1.0 tests so that we are sure that we are not introducing any bugs as we are changing replacing the code with the new stuff. And that we don't introduce any regression bugs in the Jersey 2.0 code base. So as I said, prototyping started in 2011, and we released the first public milestone, which was very limited in functionality, sometime early in 2012, in February. And with Jersey 2.0, we started to really do more of a Scrum-based project development. So we are having mostly 4 weeks. Sprints in the summer because of the vacations we prolonged. We had some 6-week development sprints. And the latest milestone that was released about a week ago is milestone 8, and currently covers about 90% of all the tests in JAX-RS 2.0. So basically we are almost on par with the JAX-RS 2.0 features already. We implemented everything. All the releases that we are doing are announced either on a Twitter or I'm on my blog. I'm blogging about every release, mentioning all the major features. So if you want to check what's being implemented, just go through the blog entries, and you should be able to get a feeling of what we are adding. As I said, since we are coming with a completely new code base, the backward compatibility is a little bit gone, also due to the JAX-RS API changes and the features being taken up there. We decided to also kind of we decided to make sure that we are also compatible, or we are following the same package and Maven group ID pattern as the rest of the Glassfish-based project. So we changed the Maven group ID as well as the root package ID, and we are creating basically new APIs based on the things that we learned in Jersey 1.0 and didn't quite work well. We are trying to make sure that in Jersey 2 it works better. Just to get you a feeling when I'm saying that that the Jersey 2.0 provides not only the reference implementation, those boxes, this is the current state of the Jersey modules, all the Maven modules that we are providing with Jersey. Don't bother with names, just to check that all those orange boxes are part of the JAX-RS API and everything else is extras. And I'm not even showing another, this is just the runtime, and I'm not showing additional extra things like all the tests that we are having there, all the examples that we are providing, the documentation and stuff like that. So as you can see, there's a lot more in Jersey than just the JAX-RS API. So if you want to leverage the additional features that are provided by Jersey, obviously you can. Okay, so now let's move on really to some of the features, and let's start with how Jersey can help you to configure, deploy, and test your applications. In JAX-RS, in a standard JAX-RS, if you are deploying an application and you want to configure it, you have two options defined by the specification. You can either just let the specification scan the class path, and all the classes annotated with add path or add provider annotation will be found and loaded to your application. This is good for development, but it's a really bad practice for production. Why? Because if you have a library that happens to have some provider that you really don't want to include, or you even don't know about it, well, obviously, and it's on the class, but you obviously don't want to include that provider in your application. So it might be even a security problem. So that's why you shouldn't do it. And instead, you should really just extend the application and override the get classes or get singleton methods, and return all the list of all the classes that should be a part of the application, whether it's resources or providers. That's well, how you do it. So you create a hash map, basically populate with all the classes. Well, sometimes you may even forget about when you add a new class to a package, you may forget about it. So that's not very convenient way how to do that. So that's why in Jersey we are coming with an extension of application class, which is a resource config. It's a mutable class, and it provides you the mutable API that Jakub will be showing in a moment for essentially adding the properties, classes, instances, even the new programmatic resources that we are adding in Jersey 2, your custom injection binders based on the injection binding API that we are exposing as a new API, as well as resource finder, so that you are not really need to add the instances and classes. You can just really tell the config to scan the particular package and find all the resources in the classes, to scan particular files and etc. And you can combine these approaches to assemble your application. So let's say even if you have your own classes residing in your own packages, you would just use the resource finders to scan your own packages, and then you know, okay, so I have this third-party library which has like millions of providers, but I want to use only those three, so just add those three to your application using this programmatic API of the resource config. Oops, sorry. As for deployment, there is a standard way how you can do it, but that standard way only lets you kind of somehow, if it's available, create an endpoint, whatever it is. And typically it may be Java SC Lightweight HTTP server endpoint or Grizzly endpoint, or well, in server deployment you are not doing that because you are just deploying to some running application server. In Jersey we are coming with a container. In Jersey 2.0 we are coming with a container SPI that exposes two main classes. One is a container provider, which basically lets you create a container, and then the container, which is the kind of represents the instance of the container and lets you do interesting things like well, start, stop, but more interesting, reload or reconfigure. Basically, you can at the runtime just change your application, pass in new configuration, pass in new resource config or the new application, and just say reload, and the container will reload with the old with the new application, while making sure that all the old clients currently communicating with the application will still don't lose connection and will still work and communicate with the old application until and once all the clients die, basically you are going to see that all the new connections, or the new client connections are going to the new version of the application. As for testing, again, how do you test the application? So in Jersey 2.0 we are coming with the Jersey test framework, where it's based on the JUnit. The Jersey test is a base class and provides a couple of methods that you may want to override and extend, so that you provide and basically the Jersey test framework is written in a way that you can test your classes in a variety of containers, because we are able to due to the container API we are able to plug in seamlessly different containers. Currently we support in memory container the JavaSC HTTP lightweight server, the Grizzly, and the external, which means that you are deploying your application to some external server, whatever it is. Typically it's a servlet based or Java EE server. And what we also plan to do in this test framework is to add support to not only for just Jersey client implementation, but also for various different implementation of the JAX-RS client API, so that you are able to really test portability even on between the different client and server implementations using the Jersey test framework. I think with that I would hand over to Jakub so that he can show you the demo of what I was just talking about.
Hello? Can you hear me? Yes. Okay, cool. So I'm going to show you a basic demo. So we'll be deploying a simple web service, and then I will be implementing a test for it, so that you make sure the resource is working fine. And this would be done using the Grizzly container that we have implemented support for in Jersey. So can you please raise your hand who has a hands-on experience with JAX-RS? Okay, quite a lot of you. So who hasn't touched it? Never. Okay, so I will be starting with, so here I have a project. The only thing I have configured there is the dependency, so I have pulled some Jersey modules in there, but otherwise I'm writing it from scratch. So we will see how to develop a Jersey-based application. So I'm going to start with adding a simple resource. So I'm creating a new Java class. I will call it session resource, and this will be really simple JAX-RS stuff. I hope you can read even from there. Could you please? Okay, thank you. So I'm going to bind the resource to the session URI. I need to import a path annotation, and I'm going to implement a simple method that would respond to HTTP GET. So this method will produce a text response, and we'll just return a string. Fixing imports, and now the string would be will be returning the ID of this session, which is con 7114, if I'm not mistaken. So that's it. I got a simple JAX-RS resource, nothing new yet. So now I'm going to create a new Jersey application that would take the resource and make it available for the client. So that will start a Grizzly container. So I will call it Jersey app, and here, Marek mentioned that we have a concept of resource config in Jersey, so I am going now to introduce the main method. This will be the main entry point for the application, and I will create a resource config and use it to start a container. So, so I'm creating the main method. Just that I don't need to bother with tie catch blocks for sake of simplicity. So now I am going to create a new resource config like this. I'm passing it the session resource class, and just to separate it from the other code, I'm going to introduce a special method for this. Called create resource config, like this. Okay. So now we have some utility methods in Jersey to start the Grizzly container. So I'm going to use our Grizzly HTTP server factory to create a Grizzly HTTP container for me. So I will pass an URI to it and the resource config. So I'm going to choose this factory method. I need a URI to bind the new application to. So I will just create a new one, attach it to local interface port 8080, and I will pass it the resource config I've just created using that utility method below. Let's see what's wrong. Let me open it up a bit. Okay. So I need to fix the imports. Okay, and I need to fix this as well. So I hope you can see just a single line of code, and I've retrieved a running HTTP Grizzly container. Maybe I should also handle stopping, so I will just wait for an input from the console like this. And then I will stop the server. So I need to keep it in a variable like this. And now if I press enter, I will just call server stop like this. So this should be it. I'm saving, and I will try to run the application to see what happens. Okay, so the container is running, and I can test it from the browser. So switching to the browser, and it should be localhost 8080. Now session, and nothing happens. Let me see. Okay, it should be all right. I didn't expect an error that early. It should be started already. So. To možný. Není. Okay. Does anybody spot any mistake? Okay, slash in the session? I don't need that.
No, that's okay.
That's true. Okay, so let me cheat a bit. I don't want to waste time, so I have a completed application here, so I will just. Sorry for that. Oh, never mind. So I will just copy this and this, or maybe I can just restart. I think it must be working. So clean and build, and hopefully
Nemáš tam nějaký, nechýba ti tam basecode?
Já to tam mám. Okay, let me copy the stuff. I'll need to show you what's going after. So let me stop this one first. Copying the application. Leave it as it is. I'm going to delete this one. And
So the only thing we can see different there is that when you're creating your resource config,
pardon?
you passed a class into that resource config constructor you were loading in a moment ago.
Yeah.
And here you're looking at the class different.
Yeah, this is different because, you know, it was supposed to be evolving during the demo. So I really don't know what's wrong. It's an early access stuff, but it didn't happen. I tried several times before. So now I'm going to rewrite a bit. So I'm going to rename first. And now I'm going to. So maybe I can stick with this configuration. So I'm using the packages method so that I can configure where Jersey should look up the resources, and this should be fine. So I'm also going to maybe copy the session resource over to here. I want to delete this one first. And okay, session resource, and now maybe I should have left it there. Anyway, so like this, and now I can try to rebuild, and hopefully
No,
it doesn't need to be there. So it's better, of course. No. The port shouldn't be taken with anything else. Wow. Let me stop this guy first, or maybe I can. This is interesting. It doesn't respond.
So maybe in the meantime, while you are debugging the session, I'm going to try to proceed with the next section, so that we. So basically, typically that works. That's and I saw it working. You can trust me. Yeah. Basically, when the basic stuff works, we can move on and try to add additional things. So another stuff that we are adding in a Jersey on top of JAX-RS, either 1.0 or even 2.0 features, are JSONs, the custom injections, the API, how to provide injection binding. Sadly enough, at the moment, not even CDI doesn't provide a completely good way how to programmatically define your custom injection bindings. I know there are ways, but it's nowhere near the API that Juice provides, for instance, as well as manage async. And I'll get back to and I'll talk about what does it mean, the manage async. So let's start with the JSON support. So again, unfortunately, there is no standard JSON parsing and binding API in Java yet. It's coming. There will be a parsing API in Java E7 introduced, there will be. I was told that "will be" is the right English phrase for something that may not happen again. But no, hopefully, let's hope it's going to happen. Still, the problem is that in the JAX-RS specification, we are releasing earlier than JSON-P, and that's why we are not able to have a hard dependency on a JSON API, even not on the JSON parser API, even if we are going to be part of the same EE platform version. And that's why we are not able to include the JSON support, not even for parsing in the JAX-RS, and we need to rely on the support provided by the implementations in a proprietary ways. So hopefully that's going to change in the maintenance release of JAX-RS 2.0 somewhere in the end of next year, or maybe early 2014. And the binding API is even further back, so it's going to come only in Java E8. And the solution for that is basically to use the Jersey JSON extensions. And basically, Jersey has media extensions not only for JSON but also for other stuff. And currently, as for JSON, Jersey provides support for all the major existing JSON Java frameworks, such as JAX and Jettison. But the new thing that is coming is a preferred way of and a preferred extension from our point of view is to use MOXy. Why? Because it provides the full JAX-B support, not only for JSON but also for XML. And obviously a couple of additional features, such as being able to use the XPath expressions on your beans, and it works not only in XML but again in JSON. So basically, we feel that MOXy is the right way to go. I think it's the most mature framework out there. Also, another thing that we are adding early in Jersey 1, if you wanted to provide support for JSON-P, which is the way of sending JSON data as a JavaScript function. So it's like basically name of a function, and then all the JSON data are inside. So for that you had to create a special wrapper for your data. In Jersey 2, you don't really need to do that. You just add annotation to your method, add JSON-P annotation, where you can specify additional things like whether you want to change the default JSON-P name from callback to whatever is custom, or whether you want to let the client specify via a query parameter the custom name of the callback. So that's all possible to configure via the annotation, and you really just return your JSON data, and it will be automatically wrapped using the JAX-RS 2.0 interceptor into a proper format. And the cool thing is that this is going to happen automatically and only if the client requests the JavaScript media type back. If it just requests the JSON, the wrapping obviously doesn't happen at all. So based on the client accept header and based on the configuration of the annotation, or based on the query parameters, you are going to be able to return back the JSON-P data. Another thing we are changing the Jersey. As I said earlier, Jersey had its own solution for injection management, and it had its own specific API which was based around injectable provider factory and injectable provider. In Jersey 2.0, we are relying on a dedicated HK2 injection manager, which is, as I said, used in Glassfish, and it provides a flexible programmatic API, so we can really just use the Fluent API to build your extensions, to build your injections, build your own custom injections, and it also provides out-of-the-box support for @inject annotation and the whole JSR 3.3.0 dependency injection API. What we are still planning to do is to leverage the planned support of HK2 to integrate with other injection managers such as CDI, Juice, and Spring, which basically for us means that all the Jersey users can use the same API to define the bindings, and then whatever is the underlying injection manager, all those new injection binding, all those new custom injection bindings will be properly propagated to that other injection manager, and also the bindings defined in the other injection managers should be vice versa available in HK2 via the integration layer. Also, another thing is that, so basically here you can see also kind of an example of an API. You can extend the abstract binder and then override the configure method. And basically, if you ever work with Juice, it's very similar. Even though, I think the Juice got the API almost right, and we got it a little bit better because in the Juice you bind the contract and another contract, and then maybe you add the service class and scope and stuff like that. But that doesn't let you retain the type information about the service. So we reversed it, and instead we are starting with the service, and so we are binding a service to a set of contracts, and by that we are able to do compile time check and and we are able to at compile time know whether this service is really supporting that contract, and we are able to show you the errors in the IDE if you are trying to bind a service to a contract that it really doesn't support, and that's something that Juice doesn't provide at all, or is not able to provide because of the other way of binding the API. As for the managed server side asynchrony, the thing is that so sometimes good features don't make it into the API for various reasons. This case, the reason is Red Hat. We have JAX-RS API comes with the asynchronous processing for services. Anybody is not familiar with the concept of asynchronous processing? Should I spend some time talking about it? Just raise your hand. Oh, okay, so not too many. Let me. So just very quickly, the thing is that when you are processing the data, typically the worker pool of the threads that are processing the data, the I/O container has only a limited set of threads, and while you are processing one request, you are not able to process the other requests if the I/O container thread is blocked by your processed request. So the principle behind asynchronous is to offload this processing to a different thread pool and let the I/O container threads be free so that all the requests can be processed basically at once, and you can use the other thread pool to really scale your processing rates better while not blocking the I/O container threads. So that's basically the main principle. One thing that you need to be aware of is that if you are offloading the processing to a different thread and you are not informing the container that you are doing it, it will automatically close the connection when the worker thread is freed, and basically you are not able to send any data back to the client side. So that's why you need to have some way of API that tells the I/O container, hey, I'm done with this thread, but please don't close the connection. I'm going to take care of it later. So that's basically the basic principle why you need a special API for asynchronous processing, and if you are offloading the processing to a different thread. So what are the options currently? You can either use the async EJBs, for spawning new threads, or you can spawn on your own thread if you're running in a Java container. Bill Shannon, the Java architect, will really frown upon you because you are not supposed to do that at all in Java container. Or you can basically pray for concurrency API to materialize in Java 7. And unlike JSON API, which really is going to happen, this one is not so sure. I'm not so sure about. So that API should provide the concurrency utilities and workers for Java 7, which would replace the need to spawn your own threads. But as I said, I'm not sure if it's going to happen. Or what you can do is to attach manage async Jersey proprietary annotation to your resource, and once you do that, you are informing the Jersey container that it should run the method in a separate thread, and automatically inform the container to not close the connection, and basically let you close the connection or send the response as it is convenient for you or for your application. So Jakub wrote me a message that it works now.
Hopefully.
And I'm switching back to him, and I let him do all the demos. Maybe you can.
Maybe I apologize for that. It was a network glitch. I unplugged everything, Wi-Fi and then the network cable, and voila, it works. So I would like to ask what do you want to see, because I don't think we have enough time to cover everything. So async, manage async support, the first thing, JSON support, then Jersey test framework. So who wants async support? Okay, Jersey test framework and JSON. Okay, that's most demanded. So I will start with JSON, then async, and then the test framework. So let's see what I have here. So this is how I left that, just to prove that it works. It started and running. So here I can. I can also try from Carol command line client. So now I will try to.
So sometimes it works even with the network.
Yeah. Using the loopback interface. So now what I will do is I will create a new bean. I will call it a session bean. Session, so that it could be used for the JSON processor to populate the JSON data. So this will be just a data POJO class. So it will have maybe an ID. Then I will put there a title, and to show you something else than just plain string values, I will also have a capacity. Just a demonstration, so we'll make it public as well, and I will ask NetBeans to give me some convenient constructor for this. So I will need no-arc one for MOXy, because I will be using MOXy to serialize JSON out, and I need another one which will take some arguments to make me happy and to be able to quickly create the instances of sessions. Okay, so that's it. I have a data POJO, and now I'm getting back to the session resource, and instead of returning string, I will just return the POJO. I will create a new one here. Well, maybe use this session data for this. So I don't recall the name. Let's call it Jersey to coding session, and capacity, I don't know.
120.
Okay, here we go. So now what I need to do, I just changed the JAX-RS resource, and I now need to get back to the resource config and make sure that I configure the JSON support properly. In Jersey 1, we had a default setting for this, but at Jersey 2 we don't have anything like that. We need to explicitly configure what kind of JSON processor you wish to use. So what I'm going to do is I'm going to update the resource config, and I will add okay, it's at binders method. I will add the MOXy binder, which is available.
So basically, the MOXy JSON binder is not only binding the providers; it's also binding its own custom injections, which it internally uses, and it's basically using this a new binding API, a new injection binding API I was talking about previously.
Okay. So now I will try to restart the application. Let's see what now I'm getting. Oh, I forgot to update the produces annotation. So I will need to specify that I'm going to produce. I can put it here or here. It's maybe better. So I'm going to use the standard JAX-RS annotation at produces, and will use application JSON media type, saving now, and going to restart again. Hopefully NetBeans will recompile for me. If not, I'm going to do it explicitly. And now let's see what happens here. So I'm asking for the same resource, and I'm getting the JSON populated for me. You can see that the capacity, it's really a number. It's not you know, like you could see maybe in Jersey 1 we had troubles to get this work. So this is marshalling of JSON. So now we are running out of time. So maybe now I can show you the manage async feature. So what I'm going to do now is I'm going to wait here for 5 seconds. I will prolong the response so that the client is not served the data right back. So I'm going to use this thread sleep method. I'm going to wait for 5,000 milliseconds. I need to fix something here. So let's see. Okay, I will use the try catch block, and now again I need to restart the application. Okay, and we'll see. I want to reload this, waiting for localhost. It's here, and now we got the response. So far so good. Just one single client. It's not an issue. So what I'm going to do is I'm going to use shell here. First, I'm going to ask for it once more to make sure it works here. A single client, and now I'm going to launch some more clients. So I will launch maybe 100 clients. And I'm going to use the curl command again, put it to the background, and I'm done. So I'm simultaneously running 100 parallel clients and asking for the resource. So you can see if I list the jobs here, and I will count them, that I got some responses back, but some clients are still running.
So that's the reason, because by default only 5 threads are available, and basically only 5 connections at a time, 5 requests can be served. So others are waiting in a queue for the worker threads to become available. So that's the sync case. That's why in some cases where you have the blocking operations, the sync case doesn't really is not a really good option.
Okay, so now I'm done. Yeah.
So thread management, is it not part of the application server? Why do you need such?
So can we answer the questions later?
Okay, so now what I'm going to do, I'm going to utilize the Jersey managed async feature. here I will be using the standard JAX-RS API, so I will use the suspended annotation. I will ask the async response to be injected here, like so. I don't need to return anything from the method. Oh, excuse me. So I will be just returning void. And here, what I want to do is I just ask the response to resume after 5 seconds, and I will pass it the data to be returned back to the client, like so. So again, I'm saving this, restarting the application. Okay, started, and now I'm doing the very same thing again. So 100 clients again simultaneously running against the server. 1, 2, 3, 4, 5. Let's see. So how many jobs is left running? 0.
So since we offloaded, basically all of the requests have been processed at once by served advanced, because those 5 threads were just passing it to the other thread pool that was really doing the sleep. Yeah.
So now I don't know whether we are going to take questions, or
I think what we can do. Do you want to see the SSC example, or do you want to take questions? Sorry? Jersey test. So you want to see test, you don't want to see SSC support. Okay.
Okay. So
who wants to see test, and who wants to see test? SSC is server sent events. So basically, we have a chunk processing. You can stream the data. There is, yeah. So we have an example of streaming data from Twitter Live, and yeah. That's not WebSocket. WebSocket is a different specification. It's not. Yeah. Okay, so if you want to see SSC, I have it kind of ready. Basically, I'm just going to show you a demo. Well, or maybe I can quickly run through the slide. So basically, we provide the important thing to know is that we are adding support for processing chunked streams, and basically in a type safe way. So we are not really you are not really needed to process it as a stream. You can just read chunks of type data, let's say messages. You can do it generically, but we have also added additional support specifically for the SSC protocol, which is currently part of the HTML5 and is also supported on a JavaScript in a browser conveniently. This is how a SSC message may look like. There is a command, and there is some ID. It's an optional. Then again, event. It's some arbitrary event name, which is also optional, and then some data, which are not optional, separated by a blank line, and then you can have another SSC event. So basically, except for data, everything else is optional. That's the format of the SSC event, and that's what you would see on an SSC stream. And we are providing some APIs for working with the SSC streams. Everything is also, this example will be part of the Jersey example, so we will be able after the session to look at the code and play with it more. So the demo, what it does is really using the Twitter streaming API, and there is something that I call Aggregator, and connects to the Twitter and streams the JSON data. It extracts only some of the JSON data into a proprietary message object, and uses a resource to put the data into the aggregating resource, where another clients can connect and get all the and stream all the messages from the resource via SSC. So this way we can use even multiple aggregators. I have a test aggregator. We just randomly send some messages. So we can turn both on, and we will see that multiple message sources are aggregated into a single stream of SSC data. Internally, the message aggregator is implemented as a Twitter client. Well, the Twitter aggregator is implemented as a Twitter client that posts the messages into the queue, and then there is aggregator client which puts the messages to the resource that is then streaming them via SSC. So let's switch to the browser now. This is basically a way. This is basically the Twitter API. You need to be logged in. Yeah, that's my Twitter account. So it requires at least basic authentication, and I'm now basically tracking hashtag beer. So all the tweets about the beer should be slowly coming up. Well, not many people are talking about beer at the moment. Oh, some more, yeah. So, okay, so these data are coming, and these are the data that are coming into the aggregator, which is then basically parsing them. This will be something that I'm going to show up a little bit later. Yeah, and this one as well. So those were the Twitter JSON data. Let me now show you the application. So this is the Swing application. As I said, I have the Twitter aggregator, which is green. It will be sending messages with the color green. The blue is the test aggregator, which just sends some random stuff. So let me add a keyword that we are going to track. We can also track for the beer. What else should we track? Oh, J1. Okay, and let me start the aggregators. Yeah, so, and basically I'm connecting I'm getting some messages here, and I'm posting it to the service. And the service is up and running. You can see the new messages are being received on the service side. And in the browser window, that's what I'm going to show. So this is the service, this is the service stream that is going to be sent back from the browser if I connect to get the SSC data. So yeah, and basically I missed first messages. So as you can see, it's basically the new messages are still coming, 178. So well, whatever. So this is again the Twitter data compressed into the form that I'm interested in. So I just want to see the text of the tweet and the profile image URL, and then I'm adding the color of the message, how it should be displayed in a client. So as I said, the SSC is part of the HTML5 standard. So there is a really nice nice support for even the JavaScript clients. Where am I? So let me show you how I can implement a very simple JavaScript client that consumes the SSC events. So basically, I have the event source listening on some URL, and then basically I'm registering a function on that source whenever a new message comes. And since I know that I'm sending the JSON data as part of the SSC event, I'm using the JSON the built-in JSON parser to parse the data, and then I'm basically producing some div to display it. So let's look at how it really works in the browser if I access the page that uses this JavaScript. Oh, as you can see, I'm basically seeing the data. The blue ones are coming from the test client, as I said. The green ones are coming live from the Twitter. And I'm displaying the profile image URI and the tweet itself. So, and in the color of the message aggregator I'm using. So that's basically the basic sample. I think we can now, as I said, we don't have time for code, so maybe we can take some questions. And we can do it even via Twitter if you want to send them to us. So let me just stop it. Remove these. So what should be the hashtag we should be listening?
Good 2 minutes, so I don't think we have.
Java.
Okay.
No. So
The JSON API that you're including as part of Jersey, because we don't know if the JSON parsing will come in for JA7, how compatible is that with the APIs that are being proposed for JA7? Will there be a lot of work to migrate from the Jersey API into that one once it does come?
Well, the question was about the JSMP API. So currently, we know how the JSMP API would look like, and we have some kind of applications already using it. So we are probably going to include this in Jersey. So that's no question about that. But what I was showing was a JSON binding API, where this is not going to be included in Java EE 7, and we will need to wait for maybe Java EE 8. It's not going to happen soon. So we have the proprietary API, and
Okay, so it's using like a third party.
yeah, third party MOXy library, and another support is provided by JSON library. So we have a provider for that. And for Jettison, we have something as well, but you can plug in your own implementation, so that shouldn't stop you from being able to use another third-party libraries.
sure. So one cool thing about the MOXy, for instance, is that as you saw, these large chunks of data that were coming from Twitter, and I was only interested in getting the text, the profile image, and then I was adding, well, from those Twitter large set of data which were nested, I really wanted just the text and the profile image, which was somewhere nested inside that. So here I'm using this message object, which is a POJO, to get the data. And basically I'm just defining, okay, so I want a text, and then I'm using XML path to get the profile image from somewhere inside. And basically, the MOXy does it for me, so it ignores all the rest of the data and just populates these two fields with the data I want. So that's really cool feature, I guess. Okay, I guess we are timed out. Yeah, we can take the questions outside. We'll be there. We need to clean up the room.